Hello viewers, welcome to my channel and thank you for watching the videos. In this video, question 15A of 1993, Operations Research UPSC CSE Maths Optional Paper 2. Use simplex method to solve. This is minimization problem. So this can be done by two ways. One, that we can solve it in this manner by minimization, so we will keep it minimizing problem. Another is that we convert into maximization problem and then solve it, and in the end when we get the value of z, we put a minus sign, so positive value we convert it into negative value. That is the procedure. So we will be doing with minimization only. All the constraints are less than equal to, so we can implement simplex method. Variables. First we will be adding the slash variables. So this is the constraint. In second S2 and in third S3 constraints are same, and in the objective function, which is minimization type, 0 S1 into plus 0 into S2 plus 0 into S3, and all the 6 variables are greater than equal to 0. Now we will be solving this problem. As we select the values, some difference is there from the maximization. So we have written cost function coefficients, which are z function coefficients which are on right hand side, and we put x1, x2, x3, 0. So we get s1, s2, s3, 0 from the first equation from here, from second equation from here, from third equation, because we have kept x1, x2, x3, 0 in constraints, and z value is coming 0 because x1, x2, x3, 0, s1, s2, s3, 0, so z value is 0. And this is our coefficient matrix, which is having the coefficients of constraints. Right hand side value, these are right hand side values denoted by xv, and we write zj minus cj. We take all the terms from right hand side to left hand side in objective function and put it as 0, and we get these values. So in notes, in operation research notes, where I have explained the method, there the table has been made with the help of Taha, and that notation has been followed. But in many books other notations have been given, so I have tried that also here. So what we do, positive value instead of most negative value in zj minus cj, we will take most positive value, and that is 3. This becomes pivot column, and key column also we say key element. Corresponding to this column, we have to find out the minimum ratio. So we divide xv by x2, the x3 elements with corresponding x2 elements we divide, and if in denominator negative, as in this case here, we will neglect it. If 0 is there, we will neglect it. So we got 3 is minimum. It means the row corresponding to this, that is S2, is the leaving variable. So S2 is leaving, and S2 is entering variable, and S2 is leaving variable. And wherever this column and row cuts, this element is pivot element or key element. We divide this row by 4 and get here 1 in pivot element, and with the help of this row we make this, means all the constraint elements in this column 0, as well as in zj minus cj we make it 0. Zj we will change, but not with the help of this, we will add Cj in Zj minus Cj and we will get this value, corresponding value all. So in the next slide I have shown the S1 row, S2 row and S3 row, which have been denoted R1 row, R2 row, R3 row, and calculation has been shown that first we divide S2 row by 4, then with the help of this row we make S1 row and element under X2 will be 0, and for S3 same, element under X2 will be 0, and in Zj minus Cj element is 0 under X2. You need not to do the calculation separately as I have shown in the next slide. Only thing, you can write the same calculation on this iteration number 1 table itself. So just for understanding that has been, we will write the pivot row. Here pivot row is R2. So R2 value is R2 odd upon 4. So after dividing by 4 we get this, and here pivot element has become 1 now. Then R1 new will be R1 old plus R2 new. So this is R1 old, R2 new, this we have calculated just now, this value, and R1 new with the help of this formula. Then R3 old we know, R2 new we have calculated, and R3 new is R3 old minus 3 R2 new. So we will get this in next iteration. These are the now values. We write down next iteration which one is most positive. This one, this is pivot element, this is pivot column, and now we will divide xb by x1. So we get 10 upon 5 upon 2, which is 4. S1 is leaving, x1 is entering, and this is pivot element. We divide S1 by 5 by 2 and make it 1, and with the help of new row, the new values, will make these elements as 0, these 3 elements, and Zj will change accordingly, because in Zj minus Cj we will add Cj and we will get Zj. So for each row corresponding elements have been calculated. Calculation on rows will be first pivot row. Pivot row is R1 row and we have to divide it by 5 by 2. It means we have to multiply by 2 by 5 and we get this row. So this element has become 1. Now R2 row is old is this one. R1 new we have calculated just now here, and 1 by 2 into R1 new is this much. R2 new will be R2 old plus 1 by 2 R1 new, and we get this. Then R3 old, R1 new, then 5 upon 2. We are multiplying it, and then we get R3 new, R3 old plus 5 by 2 into R1 new, and we get this. Once we get all the calculation values we have done on R1, R2, R3, first with pivot row, then rest of the 2 rows, and on Zj minus Cj row can be done on the iteration table and get the next iteration table, which is here, and in this we see that all are negative in Zj minus Cj. There is no positive value, either 0 or negative, so it means we got the optimal solution, and we will stop here. And what is that solution? It is 11 with minus sign, so minimum is minus 11. If we have done with maximum, then we would have been seeing the most negative in Zj minus Cj, and rest procedure was same, and once we get value of z, that would have been plus 11. For minimum we have to put minus sign on that, then it becomes minus 11.
Hello viewers, as I am uploading videos of CS main mathematics optional, UPSC syllabus and videos of solution of past year papers, this is one of them. Here I am doing question number 1E of operations research. This question is from section A and this is from CS main 2013 paper 2 mathematics. It is maximize z is equal to 2x1 plus 3x2 minus 5x3 and constraints are subject to x1 plus x2 plus x3 is equal to 7 and 2x1 minus 5x2 plus x3 is greater than equal to 10, xi greater than equal to 0, and this question is of 10 marks. Here we see that constraints are equal to sign and are of greater than equal to sign, so we have to add artificial variables and surplus variables, and basically we will solve this question with the help of big M method. So here the constraints are of type equal to and greater than equal to, so we introduce surplus. Surplus means on left hand side of the constraint here something is more, some amount is more, and artificial variables because we have equal to sign here and equal to sign here, and our LPP may be written as follows in the equation form. The objective function is here maximize z is equal to 2x1 plus 3x2 minus 5x3 plus 0s1 minus ma1 minus ma2. M is very large number and a1 a2 are artificial variables, and this is according to big M method, and because the constraints are equal to and greater than equal to sign, so we will adding artificial variables a1 and a2. So first constraint is x1 plus x2 plus x3 plus a1, this is artificial variable, is equal to 7, and second constraint is 2x1 minus 5x2 plus x3 minus s1, this is surplus, plus a2, this is artificial variable, is equal to 10, and x1 x2 x3 s1 a1 a2 are greater than equal to 0. So we have this objective function in equation form, and we write down z minus 2x1 minus 3x2 minus plus 5x3. We have taken all terms on left hand side, rather we should take here minus 0s1 and plus ma1 and ma2, ma1 plus ma2 is equal to 0. So is equal to 0. Now we write down the coefficients of z row in first row, coefficients of a1 row in second and a2 row. Here we have taken a1 and a2 are basic variables, so their values are 7 and 10, and then we have the variables x1 x2 x3 s1 s0, and a1 a2 are 7 and 10, and solution is 0 here. So in z row we have written the coefficients of z row. Coefficient of z is 1, coefficient of x1 is minus 2, minus 3 is coefficient of x2, then 5, then s1 is 0, then m and m. Similarly we have written coefficients of a1 row, this is a1 row and this is a2 row. So from here we have written the coefficients and we got this starting table. Now we should apply simplex method, but before going to simplex method we should check whether our z equation is balanced or not. So when we substitute values of x1, x2, x3, s1 as 0, we get z as here on right hand side minus ma1 minus ma2. a1 is 7, a2 is 10. So this becomes minus 17m, which is not balanced. We are writing here 0 instead of minus 17m. So first we make it balanced by using the following formula. So here we have written C solution as minus 17m, and it is compatible with a1 and a2, and x1, x2, x3, s1 are 0. Now to make it balanced, because we want to make coefficients of a1 and a2 as 0, we use this formula. New z row is equal to old z row minus a1 row into m plus a2 row into m. So we have used this formula and we got this minus 17a and coefficient of a1 a2 as 0, and rest of the terms also they have changed. Each term we are applying this formula on each term, corresponding term. So now this is a maximization problem, so we will see which term is most negative in z row. So most negative is coefficient of x1, that is minus 3m minus 2. So we make it entering variable, and this is our pivot column, and these are our solution elements. So we find out ratio by dividing solution elements by corresponding pivot elements, pivot column elements. So 7 upon 1 is 7, and 10 is here upon pivot column element is 2, so it is 5. So minimum is 5, and a2 becomes our leaving variable. This a2 row is our pivot row, and the element which is at intersection of entering variable and leaving variable is, or you can say this pivot column and pivot row is 2, is the pivot element. Now we use this pivot element to write down new a2 row. So new a2 row is a2 row upon 2, and in next table we will replace a2 by x1. So here we can write x1 instead of a2. So we have written x1 instead of a2, and we can see each term has been divided by 2 of this row. This row has been divided by 2, and we got this new row here. So this is new a2 row, which is now x1 row, and with the help of we will be writing new a1 row and new z row by using these formulas. So we see a1 row minus 1 into 1 is this element in the pivot column element into new a2 row, and for z row, new z row, we write down z row plus 2 plus 3m with this is 2 plus 3m minus sign outside. So minus minus becomes plus, 2 plus 3m into new a2 row. So by using these formula for each element we get this table. Now we will see which one is the entering variable and which one is the leaving variable. So our entering variable, if we see, this is minus m, and this is minus 7 upon 2. So this is most negative. So this is our entering variable here. And now leaving variable, we will see here that this is the pivot column, and these are the solution we will divide. Here we see this is 4 upon 7 is the ratio, and this one is negative, so we will neglect it, ignore it, and we will have this as leaving variable. So a1 is leaving variable, and our entering variable is x2. So this is our entering variable. So this is our entering variable. So this we use the formula. What we do, we divide the equation by 7 by 2, which is the pivot element now, and get new a1 row, and we replace a1 by x2 in next table, and apply the formulas, following formulas, to get the new table. So we have divided by 7 by 2, that is multiplied by 2 by 7. and a1 by x2 we have replaced. So this is a1 has been replaced by x2, and we got this new table by using these formulas. New x1 row is x1 row plus 5 by 2 into new a1 row, and new z row is z row plus 7 by 2 m plus 8 into new a1 row. We apply on each element and we get this table. Here we see in z row all elements are positive, no element is negative. It means we have reached to our optimal solution, and optimal solution gives us values. Z is equal to 102 by 7, 102 by 7, x1 is 45 by 7, and this is x1 45 by 7, x2 is 4 by 7, and x3 is not here in the solution, so x3 is 0. These are in the solution, x1 and x2. So we obtained our optimal solution. Thank you. Hello viewers, I am uploading the solutions of past year papers of UPSC CS main, as well as I am uploading the content in PPT form of UPSC syllabus on my YouTube channel, and in this video I am uploading the question number 3C of Operations Research CS main 2017 Mathematics paper 2. This question is of simplex method, and it is a maximization type problem, and it says that we have to solve the linear programming problem LPP by simplex method. So maximize z is equal to 3x1 plus 5x2 plus 4x3. This is the objective function. 3 variables are there. Subject to these are the constraints. These 3 are the constraints. 2x1 plus 3x2 is less than equal to 8. 2x1 plus 5x3 is less than equal to 10. 3x1 plus 2x2 plus 4x3 is less than equal to 15. x1, x2, x3 are greater than equal to 0. This question is of 20 marks. So we can see here that all the constraints are of less than equal to type. It means we will be adding slack variables on left hand side of the constraints, and we will make them equal to type of problem, and that is standard equation form of the problem, and then we can apply the simplex method. So first we write down the problem in the equation form, standard equation form, and we have the objective function maximize z is equal to 3x1 plus 5x2 plus 4x3, and this is the first constraint 2x1 plus 3x2 plus s1. S1 is the slack variable is equal to 8. 2x1 plus 5x3 plus s2, this is second slack variable, is equal to 10. Third constraint is 3x1 plus 2x2 plus 4x3 plus s3 is equal to 15. x1, x2, x3, s1, s2, s3 are greater than equal to 0. So we can also add here 0 into s1 plus 0 into s2 plus 0 into s3. So we can add in the objective function because we have added these slack variables in the constraints. Now we can write down the objective function as that we take all the terms which are on right hand side towards left hand side. So z minus 3x1 minus 5x2 minus 4x3 is equal to 0. Here we can write down minus 0 into s1, minus 0 into s2, minus 0 into s3 to make it more appropriate, or to see that s1, s2, s3 are also in consideration, because we will be writing their coefficients also in the table when we will be doing the calculations for simplex method. So this we will write down the starting simplex method, and here we take s1, s2, s3 as basic variables, and x1, x2, x3 are non-basic variables, and we take their value as 0. So when we put x1, x2, x3 in first constraint as 0, we get S1 as 8. From second constraint we get S2 as 10 after putting x1, x2, x3 as 0. From third constraint we get S3. S3 is 15, and first row, that is Z row, we have written with the help of objective function. When we put all the elements which were on right hand side, we brought them to left hand side and we have written this Z row. So coefficient of Z is 1 in objective function. After taking all terms on left hand side, coefficient of x1 is -3, coefficient of x2 is -5, coefficient of x3 is -4, S1 is 0. This is -0, but we may take it as 0. S2 is 0, S3 is 0, and solution is 0. And S1 row shows the first constraint's coefficients. So we write down coefficients of first constraint in S1 row, coefficients of second constraint in S2 row, and in S3 row coefficients of third constraint. So S1 row is coefficient of Z is 0, coefficient of x1 is 2, coefficient of x2 is 3, coefficient of x3 is 0, S1 is 1, S2 is 0, S3 is 0, and right hand side is 8. So we write similarly coefficients of S2 row and S3 row. Now because this is a maximization problem, so in Z row we will check which one is the maximum negative, most negative element. So -5 is most negative element, and this we have marked here, and this becomes x2 becomes entering variable, and this column becomes pivot column. And now we have to find out which one will be the leaving variable. So for finding leaving variable, we divide elements of solution column by corresponding elements of pivot column. So 8 upon 3, and this is 10 upon 0 here, so we won't take it, we will ignore it, which comes infinity. If element is negative, ratio is negative or infinity, we will ignore them. And in S3 row it comes 15 upon 2. So which one is minimum, we will take that for ratio. So and we will mark that variable as leaving variable. So 8 upon 3 ratio is minimum in this column, and S1 becomes leaving variable, which is corresponding to minimum ratio, that is 8 upon 3. So x2 will enter and S1 will leave. Now the intersecting element of pivot column, this is pivot column, and S1 row becomes pivot row. So intersecting element of pivot column and pivot row is pivot element. This is 3. 3 is the pivot element. Now for further calculations, what will we do? We will divide this pivot row by pivot element, that is by 3. So each element of S1 row, that is 0, 2, 0, 1, 0, 0, they will be divided by 3. Once we get new S1 row, and in next table we will write here x2, because x2 will enter, and we will be having new row after dividing 3. With the help of that new row, we will be writing Z, S2, S3 rows. So we will see in next slide. 2.68 upon 3 is minimum. Ignore this, I have written here everything whatever I have explained. So for writing Z row, S1 row and S2 row, S1 row is pivot row. So S1 row is pivot row, we will be writing current pivot row upon pivot element. So S1 row is here current pivot row, and pivot element was 3. So we will get new pivot row by using this formula. And for other rows, that is Z, S2, S3, we will be using this formula. New row will be current row minus its pivot column coefficient into new pivot row. So by using these formulas, we will be getting new table. So this is the new table which we have obtained after applying the formulas which were given in the previous slide. So in each element I have written the calculation, and let's see how we have done that. So here our new basic solution is now S1 is gone, so new basic solution is S2 X2 S3. So this is the new basic solution S2 S3, and we see that X2 has entered, and we have obtained this row by dividing the current row by 3. So pivot row has been divided by 3 and we got this row. With the help of this row, we will be writing the elements of Z, S2 and S3 row. So let's see how we have done the calculation. So 1 was the element in the previous table. So 1 minus 5 was the element in the pivot column of entering variable. Pivot column, that is X2 variable, that is -5. So 1 minus -5 into 0 gives us 1. Then -3 was the element in X1 column, -5 is the element in pivot column, into 2 by 3 gives us 1 by 3. Then here -5, this was the element in pivot column, minus -5, that becomes plus, into 1, this is the 1, which gives us 0. Then -4 was the element in the previous table, -5 into 0 gives us -4. Then here coefficient of S1 was 0, so 0 minus -5 into 1 by 3 becomes plus 5 by 3. And in S2 and S3 coefficients, 0 minus -5 into 0 gives us 0. Then 0 minus -5 into 0 gives us 0, and solution was 0 in the previous table. -5 into 8 upon 3 gives us 40 by 3. Similarly, we can write down elements of S2 and S3 row, which I have written here, and then we check again in Z row that which one is most negative. So we see here -4 is most negative. So this becomes our entering variable, and this column becomes our pivot column. And for finding the leaving variable, we will divide the solution column by corresponding elements of pivot column. So 8 upon 3 is this element, upon 0 gives us infinity. Then 14 upon 3 divided by 5 is 0.93. Then 4 is pivot element column, pivot column element. So 29 upon 3 upon 4 gives us 7.4, I believe 7.4. So this is 29 upon 12, not 7. 29 upon 12. So this one is the minimum, and this is the leaving variable. The corresponding variable is the leaving variable, that is S2. So now this becomes our pivot row, and this element 5 becomes pivot element, and we will divide this row by 5 to get the new pivot row. Once we divide it by 5, we will get new row, and with the help of that new row we will be writing x2 and s3 rows, and in next table x3 will enter in the table and s2 will leave. So let's go to next table. These are the formulas which I have used to write the next table. So here again the calculation is in similar manner as we did in the previous one. So I have written all the terms here. Let's see here, x2 was earlier there, now x3 has entered into the picture and s3 is still there. And when we do the calculation as we did in the previous, so each element calculation has been written here, and we see this becomes minimum and this becomes leaving variable, and again we do, this becomes our pivot row, and this is most negative, so this becomes our entering variable. So x1 will enter in the solution, and this element is our pivot element. We will do the calculation again by using these formulas, and after using these formulas we can see what comes in the next table. After doing the calculations we get this new table, and here we see this is z row. Now our basic variables are x2, x3, x1, and solution is 765 upon 41. x2 value is this, x3 value is this, and x1 value is this. So when we see that all elements in z row are positive, there is no negative element in z row, it means we have reached to our optimal solution, because it was a maximization type problem. So we can stop here, and our optimal solution is 765 upon 41. So maximize z is this, x1 is 89 upon 41, x2 is 50 upon 41, x3 is 62 upon 41. So this is our solution. And hello viewers, I am uploading the videos of mathematics optional CS main UPSC syllabus, and I am also uploading the solved questions of past year papers, and these are question wise, and I think and I hope that you will be finding them helpful. And I am also having model papers for coming years, so if you want to have model papers and you want them to be checked, then you can send them to me. First take the model papers and then send them to me after doing, and they can be checked and sent back to you. So this video is of question 4C of operations research. This question is from section A, and this is CS main 2013 paper 2 mathematics. This question is minimize z is equal to 5x1 minus 4x2 plus 6x3 minus 8x4 subject to the characteristics x1 plus 2x2 minus 2x3 plus 4x4 is less than equal to 40, 2x1 minus x2 plus x3 plus 2x4 is less than equal to 8, 4x1 minus 2x2 plus x3 minus x4 is less than equal to 10, xi is greater than equal to 0, and this question is of 20 marks. So we see all the constraints are of less than equal to, so we can solve this by simplex method. Here this question is of minimization type, so we can solve this question by two ways. First is that we can solve this problem as maximization problem. The only difference is that when we see or check for entering variable, then in z row we check for most negative element in z row, but when we are doing for minimization we will be checking for most positive element in z row, and for leaving variable the criteria will be same. Second is that we can convert this into maximization problem by the help of this formula, that maximize z is equal to minus min minus z, and then solve it as a maximization problem. So let's do by using this one here. So what I do here, minus this sign we will add in the end of the problem. This minus z we are incorporating. So first, when we convert the problem to maximization type and then introducing the slack variables, because these are less than equal to sign, so we will introduce slack variables, because on left hand side the quantity is something less, so we will add some amount, that is slack variable, and we write the standard form of the problem as follows. So maximize z is equal to minus 5x1. See here, I have changed the sign of 5x1 to minus 5x1. So all variables will be changed, their sign will be changed. So 4x1, 4x2 minus 6x3 plus 8x4 and plus 0s1 plus 0s2 plus 0s3. So we have written this objective function after changing the sign of the variables, subject to the constraints x1 plus 2x2 minus 2x3 plus 4x4 is equal to 40 when we added this slack variable plus s1 on left hand side. Second is 2x1 minus x2 plus x3 plus 2x4 plus s2, this is the slack variable, so for second constraint, is equal to 8, and 4x1 minus 2x2 plus x3 minus x4 plus s3 is equal to 10. x1, x2, x3, s1, s2, s3, these are greater than equal to 0. Now we will solve it by simplex method. So what we do, we write z equation by taking all elements of z row on left hand side and making right hand side as 0. So we have written this objective function z plus 5x1 minus 4x2 plus 6x3 minus 8x4 is equal to 0. We tried the starting table here and we have taken basic variables as s1, s2, s3. These are the basic variables, and we take values of x1, x2, x3, x4 as 0. These are non-basic variables. So we can write down the table. First, z row. So in z row we have written coefficients of z objective function, which we have written in the equation form. So this is 1, 5, minus 4, 6, minus 8, 0. This is coefficient of s1, s2, s3. So they will be minus 0 s1 minus 0 s2 minus 0 s3 can be written as 0, 0, 0 is equal to solution, which is 0. Now s1 row is the first constraint row, and we have written coefficients of first constraint here. Coefficient of z is 0 in first constraint, and coefficient of x1 is 1, x2 is 2, x3 is minus 2, x4 is 4, s1 is 1, and s2, s3 are 0, 0, and right hand side is 40. S2 row is coefficient of z is 0, coefficient of x1 is 2, x2 is minus 1, x3 is 1, x4 is 2, s1 is 0, s2 is 1, and s3 is 0, and right hand side, that is solution, is 8. Similarly, we can write down the s3 row by writing the coefficients of all the variables in this, and right hand side is 10. So we got this starting table, and now because we have made it as a maximization problem, we will check which one is the most negative. If it would have been a minimization problem, and if we would have taken the equation as it is, which is given in the question, we could have checked, we should have checked for most positive element when this is a problem of minimization type. But now it is a maximization type problem, we will check for most negative, that is minus 8 here. So this becomes our entering variable, and this column becomes our pivot column, and for finding leaving variable, we check the ratio of solution and the corresponding element of pivot column. So 40 upon 4 we get 10, then 8 upon 2 we get 4, and 10 upon minus 1, this is negative, so we will neglect it. If it is infinity or negative, we neglect it. So our minimum is 4 here, and this 4 is corresponding to S2, so our leaving variable is S2. So in next table our X4 will enter and S2 will leave. So this row will become in next table X4 row, and this element, which is the element which is at the cross section of pivot row and pivot column, because S2 row is pivot row now and this column X4 column is pivot column. So at the intersecting of these two we have this element 2, and this element is pivot element. So what will we do? We will divide this pivot row by this element 2, and we get new S2 row, which will be X4 row in next table, and with the help of this new row we will change our Z, S1 and S3 row by using the following formula. Pivot element is 2, so we will divide the pivot row by 2, that is new S2 row we obtained by dividing S2 row by pivot element, and we replace S2 by X4. So we got here X4, and we got these elements after dividing by 2. The S2 row we have divided by 2 and we got all these elements. With the new S2 row we will obtain new S1 row, new S3 row and new Z row. So we will obtain by using these formulas which are here, and with the help of these formulas we will get new Z row, new S1 row, new S3 row. So let's see how we got this 13 and minus 8. We will do for these two, and in similar manner we can do all the elements. So in the previous table, if you see the coefficient of x1, that is 5. So 5 plus 8, this 8 has come by minus 1 into minus 8 is plus 8 into S2 new row. S2 new row is 1 here, so we get 5 plus 8, this is equal to 13, and coefficient of x2, that is in previous table, is minus 4. So minus 4 plus 8 into S2 new row. S2 new row is minus half. So minus 4 is equal to minus 8. In similar manner we can calculate all the elements of this table, and we decide for entering variable by selecting that most negative element in Z row. So most negative element in Z row is minus 8, and this becomes entering variable, and this becomes our pivot column, and we find leaving variable by dividing the solution elements by corresponding pivot column elements. So here 24 upon 4, this 4 of pivot column, we get 6 ratio value, and next two values minus half and minus 5 by 2 will give us negative values, so we will ignore them. If value is negative or infinity, we will ignore them, and then we see that 6 is the only element, so our S1 becomes leaving variable, and this row becomes our pivot row, and this 4 element which is at the intersection of entering variable and leaving variable, that is pivot column and pivot row, becomes our pivot element. So we divide S1 row by 4 and we get new S1 row, and replace S1 by X2. S1 by X2 we replace. So now with the help of this row, which we will have new S1 row, we will write new X4, new S3 and new Z row by using these formulas which have been written on right hand side. So X1, X4 row, S3 row, Z row, and these are with the help of S1 new row we have written, and these are corresponding elements of pivot, which is here for x4 row this is minus half, so minus half gives you plus half. For S3 row it is 5 by 2 with minus sign, so minus 5 by 2 becomes plus 5 by 2. And for Z row this is minus 8, so minus 8 becomes plus 8. So these are the elements we got here, and these are the old rows, x4 row, S3 row, Z row, and these are S1 new row, S1 new row, S1 new row. So we use these formulas, and with the help of these formulas we will write the next table is this one. When we did that exercise, we used those formula, we got this table, and as we did 2 elements in the previous table, same way we will solve this. We will check Z row. Here no element is negative, therefore we got the Z value as 80, and x1 is 0 because x1 is not existing in basic solution, x2 is 6 which is here, x4 is 7, x3 is not existing in the basic, so x3 is 0 and x4 is 7, x3 is coming 29. So this is the maximize of Z. So as I said, we will add this minus sign now. So our Z value is minus negative, x1 is 0, x2 is 6, x3 is 0 and x4 is 7. When we substitute these values of x2 as 6, value of x4 as 7, we get minus 80 in Z function or equation. So we got our solution here, minimization of Z is minus 80. So as we did this question with the help of converting the problem into maximization form first, we could have done this problem by doing minimization form itself. Only thing, the difference would have been that we would have checked the most positive element in Z row when we are selecting for entering variable. Rest will be same. Thank you.